you can share your screen. Let me just make you a host and share your screen if you're logged in into a screen, because and then you can share. Let me stop sharing and then yeah.
Hello.
Yeah, you can share your screen if you are connected to a laptop. Hello.
Ambrose helped me and we fixed it.
Okay.
And also I deployed my coin.
On the Ganache blockchain.
No, the assignment you gave us.
Oh, okay. Yeah. So what I wanted to know is, were you able to resolve your truffle error? Yes.
Let me share the screen. Yes, I was able.
Okay. You can share then.
Yeah. It's okay.
Okay, it's okay. Awesome. That is really awesome. Yeah. So I see you have also started doing something with Ban. Yeah. Very Ban. Yes. See, guys, I see you guys are on fire. You just want to burn things. Yeah, so that is awesome. That is really awesome. And yeah, so we also have wow, somebody who was talking to me and I led the text. So today we will be continuing on our development, which will be really interesting because now we are kind of creating a swap. Actually, we are creating a swap, something the birth of Uniswap, swap ADS. Yeah. So let me open my file that we were working on yesterday. So wow. And let me share. Okay. Don't know if we will spend a lot, maybe 1 hour. So we will end at 5. 1 hour will be okay. So that then we can, if that's okay.
Okay.
Yeah.
That'll be fine.
Okay. Yeah. So yesterday we deployed ADS using Truffle config, and we were also able to Truffle console to interact with our token, and we were also able to see the difference, the same functions that we had. So today we will be doing more. You realize that I haven't added the safe math. You realize that I haven't added the safe math, and you realize that I haven't added a safe math, but I will be adding it later. So yeah, so the other point will be now creating the ETH on token swap, on the token swap. So I'll just be referring to this code that I had written, ETH swap. Yeah, so I'm calling it ETH swap, and yeah. So for faster development, we will be using this one. So never mind my computer. I have a lot of, I was working really late today. So yeah, so we'll create a new file that we'll call it ethswap dot sol. So it should create the SOL. So remember, when you are deploying, to always make sure that Ganache is running. Ganache is running. So just like it's our norm, we will start with pragma solidity, and then that is 0.5.0, and then should be the, and then we will import our token. So import put ADS dot sol. So we are importing our token there, and then we will initiate the contract name. Contract name is eth swap, and there. So we'll have a string. This is just a way to refer to the contract. It's not necessarily if you, but it's a good thing to use to name your contract. So it will be ethswap instant exchange. So kind of an exchange, a very fast exchange where you don't need to like fill a lot of things and wait for. Then we will have public. So this one should be ADS and not token, but ADS public token. Then uint public rate equals 1,100. So this will be the rate. So for one ETH, we will have 1,100 ADS, and then we will have event. We will emit event tokens purchased. So we will emit an event token purchase with address, the address of the account. That is our contract. This contract. So because every contract you deploy on blockchain, so long as they are not interlinked together, if they are not interlinked together, like they are not connected to the main contract, definitely different contracts, all contracts normally have, they all have their own address. So we'll have the token. So this token, the address of the token, and have comma. So account token should have, and then we will have uint amount, uint rate. Yeah. So we'll have the amount and the rate of exchange, and then we will have to emit another event, that is event tokens sold. So this is the amount of tokens that has been sold. So we have address, the same thing, and account. So address, it will be the name of the address which we have given it the variable, because in this case address can be anything, but we really need to identify which address. So it's the account address that has the token. Then we have token, Then from token, we have uint amount. And then you have uint rate. Yeah. Then we have the constructor. So we have the constructor. We have to like show this token inside the constructor. So constructor is very useful because it shows what we want to display. And then we have to make it public. So like that. That is token, token and token. So it shouldn't be, it should be ADS or just token. It doesn't token or token. So we have token. We have token as underscore token. So this means that the token that we will be this means that the token that will be sent should be it should be ADS. Yeah, it should be ADS. Should be ADS because we are referring to this ADS and giving it the variable, this variable. So we will be storing that contract there so that we are able to use it. So in our contract, we will only have two functions. Actually, we will be done with the backend. We'll have two functions, the buy tokens and the sell token. Buy and sell token. So we'll first create the first one, that is function buy. So function buy, buy token. So this will be function buy tokens. So this is the function to buy token or to swap tokens if you want to be able to do that. So payable. And it should be payable. So the reason why we are saying that it should be payable, it should be able to accept ETH. It should be able to accept ETH. That's what payable means. So if a function is a payable function, it should be able to accept ETH. Then we will have the first part, that is uint, token amount. So we will define the amount that wants to be bought. Declare the amount that wants to be bought is equals to or the amount that you will get. So it calculates the number of tokens to buy using the rate. So we'll have ms g dot value multiplied by the rate. So you remember the rate that we have is 100 tokens. It's 100 tokens. Okay. So I'm not sure why. Yeah. So yeah. So this will be the amount. So if we have message dot value is a value for, it's a data type or a public variable that has been defined to identify value in ETH. So this will by default it requires the value of ETH. That is the message dot value. So the value that you have, any figure that you have that represent Ethereum, that is in Ethereum, because we don't know the users how many ETH they have. So we can have a user who has like 0.6 ETH. We don't know. We can have another one having 100 ETH or 1,000 ETH. And we don't know, or 10,000 ETH, we don't know. So that's the reason why we are just saying message dot value. So it's any value multiplied by the rate. So if you have like 2 ETH, obviously, if we multiply 2 ETH by the rate, you will get 200 ADS. Yeah. Then we will do a transfer. So remember, our function transfer is here, is in the ads.token, ads.token.sol. So what we will do here is that this function is public, so we can be able to use it in another contract. So we will do, you remember we have defined it here as token. Here, this ADS as token. So what we will do token dot, we will be calling the function. As you can see, if you have a good text editor, it will definitely show you all the functions that are available for you to use automatically. So we want to use the function transfer. We'll select function transfer, and as you can see, it has completed auto-filled my values. It has 2 and value, so it has already inputted my parameter, but I'm going to change this parameter because I don't know the sender. I don't want us to input the sender because we are just swapping for ourselves. So we'll have message dot sender. We'll have message dot sender, and then we will have this value as the parameter. So this amount that we have exchanged will be, we have defined that the value, the total amount that will be 200. So if I have 2 ETH, we multiplied by the rate, we will get by the rate that will be 200. So this amount should be here. So this is the amount that we are transferring to this particular sender. Then after that, we will emit the event tokens purchased. So token purchased will have a message msg dot sender. We'll have the address of the sender like this one, and then we will have address of the token. So we'll have the address of our token, from ADS once we deploy our contract. Then we will have the total amount, this one. So this is the total amount of the tokens that have been purchased. So we'll have token amount, and then rate will be rate. So rate will just be rate. So we have already been we are done with our function. So there is something that I've actually not added, and that will be require. We did I didn't see that I needed to like add require. So here we will add require token dot balance. So you will require the balances of the user. So this will be checking whether the user has enough token, whether the user have enough token, and address, that will be address dot this. So this is a keyword specifying to the already selected address, and then we will check whether it's greater or equals to the amount. So the normal way we do, the variable naming can be changed, can be the only thing which is have changed, but it's the same thing that we do. So you have to check whether from the token, so you have to check the token that the user is holding in specifically the function balance of from the token. You have to check whether they have the address. So from the mapping of balances of, then we can be able to now check whether a particular address has this amount of token if they want to buy, or if they have this amount of ETH when they want to buy. So yeah, but for this particular purpose, we are looking whether they have enough tokens to buy the ETH. Yeah. So, and yeah, then our function is complete. That is our function, it's complete. And then we now move on to the last function, that is function sell tokens. And yeah, so our function sell token, we will only have you int. We will only have you int amount as our parameter. Amount is our parameter public there. So then we will require the balance. So we will require, again, we will require to check the balance of our tokens if they have enough tokens to sell. Token dot balance of. So with a good text editor, you can be able to predict what people want to, what you want to write. So we'll have message or MSG sender, which we will look inside that address. So the difference between MSG value and sender is just one is for value and the other one is for addresses. So one is for checking the amount of the balances and the other one is for the address. Yeah, so we will check whether they have sorry, I've written it, it should be the other way, greater or equals to and amount. Yeah, so we will be checking whether they have enough. Yes.
Where we have a function buy tokens, do you also check if the person, you say that the amount he wants to buy should be greater than or equal to token amount? Yeah. Where do you check for fees? Like, so they also check if you have enough for buying plus paying for fees.
So the buying for fees and the buying for fee is automatic. It's already inbuilt for it's inbuilt. Though for corporate algorithms or for corporate places like Uniswap, they have a sophisticated method for doing that. They have a way that they can be able to reduce that. Yeah, but mainly one of the reason why fees goes up is because of the miners. Because if you want your transaction to go fast, then you will have to increase the gas fee. Yeah, but yeah, you can specify here on Truffle, here inside here on Truffle config while you are deploying how you want your gas fee to be. But the best thing is that if you are able to like reuse the function, as you can see, instead of writing this function again, I'm just reusing some of these things instead of rewriting them, so that the gas reduces. If you specifically for function burn and meet, they normally use a lot of gas because they are special functions. And also for delegated calls, I'll give you a link where you can be able to like read more about on the standards and the operations that happen on the Ethereum, so that you can be able to like know the gas fee, how you can be able to structure your functions so that you use less gas fee on operations. Yeah. I hope that one has answered your question.
Yes.
Okay. So we have to now check whether they have the amount that they claim that they want to sell. So
quick one.
yes.
You know, from where you are defining the set token right now, require is a greater or equal to underscore amount.
Yeah.
Supposing I just decide to put this amount, any effect?
Supposing
we ignore the underscore before the amount, we just put is greater or equal to amount.
Okay, this is how we have defined our variable here. This is how we have declared our variable with an underscore. The reason why is yeah. The reason why we have underscore, it's because on this other side, we might have another amount. We might have another amount. Yeah, I think we might have another amount. That's why sometimes I'm using underscores and yeah, so that we are able to differentiate different variables in different yeah functions. Yeah, because because maybe in function approve, you see we have another value here and we have another value here, so we want to like identify globally. Yeah, it's a coding standard for Ethereum. It's a coding standard for Ethereum or for Solidity in yeah. So then we have required whether they have the actual balance and whether they do that. Yeah. So this time we will calculate the amount of ETH to redeem using the amount. So we will divide the amount. Let's say we want to sell the 200 coins. So we will divide 200 over 100, of which it will remain 2, which means that we will get to 2 ETH. So uint, so here I can actually write it as a comment. Our amount should be 200 yeah, divided by 100, which it will be equals to 2 ETH. So that's what we should be able to get. We should get to ETH. We should get to ETH. So that's it on ETH. Then we declare that ETH either amount. So the either amount that we should get equals to amount of coins that we have entered, and then divided by the rate. So you see the importance of kind of declaring variable. You just access them in any function. Instead of like here, we would have written 100 multiplied by 100, and here we would have written it by 100. But we declared a variable here, and then we are using it. Yeah. So that's how you kind of optimize your code for better usability. And yeah, then the other one we will require that you have enough ETH. Requires that the ETH swap has to be enough. So it requires that you have enough ETH to do the transaction. So it requires you to have enough ETH to do transaction. So require address that the address has enough ETH to do a transaction, and then it will be dot balance should be greater or equals to either amount that you should be, that it should have the enough amount that the address that you are swapping from has enough amount. Yeah. Then now the last part is perform sale. So later on, like now you do the sale. So you see now, this is where the function transfer from now comes in. Function transfer, and you remember function transfer has the approval. So if we go back to our contract, that is transfer from, it has allowance. And allowance is in part of approval. So allowance is part of approval, and transfer from, you have to do allowance. So remember, these tokens that we said that we want to get to ETH, so you have to allow them and then transfer from. You have to give allowance that these 2 ETH should go to this particular address, or these tokens should go to this particular address. Yeah, actually it's the tokens. So these tokens should go to this particular other address. They should go to this other address. So you are transferring from the contract ADS to the other address, so that you in return you get to ETH. So you have to allow, yeah, because yeah. So token dot transfer from. So from, it takes 3 parameters. So we will do the same message, msg sender, and then we will have address this, and then we will have our amount instead of value amount. Yeah. And then we will have now do the transfer. Now after approval, we will do the transfer. So it will be msg dot sender dot transfer. Then you transfer the either amount. So after transferring these tokens, then you transfer the ETH. So this one is doing 2 things. It's doing transfer of tokens and approval of tokens. So those are the 2 functions that this line of code is doing. Then the second one is doing transfer of ETH. It's doing a transfer of ETH to the swapper, or the swap. Doing transfer of ETH. Yeah. So that's the only function that it's doing. So you have approved that this token you want to sell from here. You want to sell this amount. So you just want to, you need to approve, and then you have to check, you have to divide the ETH rate from the amount that of tokens that you want to sell, the 200 tokens. Once you divide it, you check whether the balance that wants to swap has greater or equals to the ETH amount that you want. That ETH amount is 2. So the account that will be receiving the tokens, the 200 tokens. Let's say, for example, Damaris is selling 200 tokens, and Ambrose wants to have 3 ETH. So we will check in Ambrose's account whether whether Ambrose has greater or equal amount of 2 ETH, and then we will do. So if the address, Ambrose's address, fulfills the conditions, then we will transfer the tokens from, we will approve and transfer the tokens from Damaris' account. And then the second thing, the tokens from Ambrose's account will be transferred using this. ETH will be transferred using this. Yeah. So ETH will be transferred to Damaris, and tokens will be approved. First, they will be approved, and then they will be transferred from Damaris. Yeah, that's why it's called transfer from. Yeah, once you have been in, you have approved. So then we will emit. Lastly, we will emit as our catcher. We will always have to emit an event. So emit token, tokens sold. So token sold contains the account, that is message or MSG sender. I don't know why I call it message, but I don't know whether the full name is message. Well, it's for those who know Ankoroja, they know MSG. It's a flavor. It's like Royco Cube or something. Yeah. So Ethereum is king of MSG flavors. So you have amount, the same thing that we have done with tokens purchased. We will emit the address of the person receiving, the address of the account, and then we will emit the amount, and then we will emit the rate. Yeah, so we have been able to complete our ETH swap or our swap contract. Yeah, so there is something, can you repeat what public payable mean? Yeah, so I think I can do that. So public payable or payable means that the function should be payable, should be able to receive ETH. The function should be able to receive ETH. That's what it means. So if a contract is not payable, it means that the contract cannot be able to receive ETH, or the function cannot be able to receive ETH. So in the beginning, before the upgrades of Solidity, payable was only available there, or it's a callback function. It's also a callback function. So a callback function is a function that just a minute. Okay, Lord, I told this guy not to disturb me. Just a minute. Well, some people really don't understand the meaning of any. So a payable function is like I have said, is or making a function payable. It means that that function can receive funds in form of ETH in your contract. So yeah, that's the basic like that's what it really means, that you need to make it payable so that it can be able to receive it. So like right now, what you are doing is that you are trying to buy, you have ETH, but you want to buy ADS. You want to buy ADS. Like the one for selling, we haven't made it payable because we are not accepting ETH. We are wanting ETH. We are wanting with ETH, and that's why we have used transfer. Message.transfer. These are some of the message.transfer is a transfer. You can use message.transfer because it's already declared inside the EVM. It will know that you are transferring ETH. It will automatically know that you are transferring ETH. Yeah. But for payable, you have to make your function payable or your contract payable so that you can be able to receive ETH. Yeah. So when you are also creating ERC20 token, if you want your ERC20 token, right now this ERC20 token cannot receive ETH. But if I just type here payable, if I write there payable, now my contract can be able to receive ETH. My contract can be able to receive ETH. And that's what normally happens when you're doing ICO. You make your function, you make your contract payable so that you can be able to receive ETH, so that people can be able to buy coins. Let me show you something similar before we continue to deploying. So let me say, for example, I want to buy into Ubrecoin. So let's just go to Ubrecoin. Yeah, so we had created a callback function. So there has been some upgrade because these days we don't really light it like that. So it's a fallback function and also payable to buy tokens from contract by sending ETH. Yeah, you have to make it payable. So this means that if I want to buy Ubrecoins, I'll just come here. I should be able to copy the contract address was there. So I should be able to like copy this contract. The token that we deployed was not payable. I should be able to copy this one. Should be able to copy that one and paste it there and then send the ETH. And I should be able to send recipient, and I can now be able to like send like one ETH. And then in return, I should receive UBNs worth that amount. So from the rate, we had written the rate for one ETH is equals to 1,000 UBN. So I'll be able to like get 1,000.
We are not in that screen. Sorry, we are not in that screen of UBN. You are explaining.
Okay. There we have it. I'm actually opening. I've opened the MetaMask. So if I want to send coins, if I want to buy and I don't want to buy from the exchange, I want to buy directly from the contract address, I will just copy this address of which I have done and pasted it here. And then I'll put the amount of ETH that I want to send, and then I'll send. So for the rate of UBN, I had written it to 1,000. 1,000 UBNs is equals to 1 ETH. So if I send 1 ETH, I should be able to get 1,000 UBNs, and they should definitely they should go to the owner's address or come into the contract address. So they should be displayed here. They should be displayed here, or if the contract has owner, because definitely mine has an owner, it has an owner, it should come here. It should come here. It should go to the owner's address. That's what I'm trying to say. It should go to the owner's address. Alternatively, it should come here, and then you can now be able to withdraw the token once the contract or the ICO is over. Yeah. So there is a lot of things or technical things that really happen in smart contracts, and yeah. So what I was trying to what I was why I told you to like research more on ownable and ban function is because those are some of the security things or security fallbacks that you can always be able to have. You can always change the owner. You can always ban people's coin if they misbehave or they steal coins. You can always ban, or you can freeze the account. So that's something else you can do. Yeah, if you ever go out there to create a coin, and those are some of the features that you can add in your coin. Those are some of the features that you can be able to add in your coin, and yeah, those are some of the things that if somebody ever consult you to like create, you will be able to tell them that these are the features I can be able to provide for the coin. These are the features I can be able to provide for my smart contract, and stuff like that. Yeah. So then, yeah. So that's it on payable function. And yeah. So so yeah, now we have been able to complete our token, our ELC, and then we are about to actually a few minutes to 5. So once you deploy a smart contract, let me just change my workspace because I was in another workspace, and yeah. So let me switch my workspace. Or I can just deploy on that workspace. Because I don't even remember what name was it. Don't remember the name of okay, let me just use this, but I know the if balance is low. So once you deploy a contract, there is no way that you can be able to like delete that contract. So the thing you can only do is trafo -- reset. Reset. Let me just see help. Trafo help. But I'm able to. Yeah, so these are some of the commands that you can be able to use. And one of them is trafo, should be trafo reset. There should be trafo reset. I guess they removed it. Yeah, I guess they removed it, but there should be trafo reset. There should be trafo reset. I think they removed it with the new updates. Yeah, so yeah, so once you deploy a contract to a network, you can't be able to like reset. You can't be able to like delete that contract once you have deployed. The only thing you can do is to reset. Resetting basically means that you are deleting these ABIs so that you can have other ABIs. So there is a lot of commands here, but mainly for our case, we will do like trafo install, trafo migrate, trafo networks, trafo obtains. So for now, like we can try and check trafo networks, net, and see the networks that we have. And then trafo and bots. So we have seen trafo and bots, trafo version. Trafo version is the versions that we are using. So as you can see, these are the networks that we are doing. So closely inspect the deployed network below and use trafo-network to remove any network that does not match your configuration. So you can also do trafo --screen to do that. And then you have this, the contract. We have been deployed. It has been deployed to this Ganache. It has been deployed to Ganache. So yeah, so that's the, if you want to see where your smart contract has been deployed. So if we have, and currently it's development, if we have another like mainnet or link bay, then we can have link bay available here. That means that our contract has been deployed in Truffle and not Truffle, but main network and link bay. So yeah, on Monday I'll show you. Once we have completed this on Monday, Tuesday we'll be able to like deploy to Truffle using Infura. So that's it on Truffle. You can see, you can always do Truffle help to see the other commands if you forget them. But once you get them into your fingertip, zitakuwa tu, they will be up or two. Yeah, so what I'll do, I don't know whether this one has changed. Okay. This is not the wallet that I was working with, but it will do us. So I'll just add the project again so that desktop, and then it was ADS. There is some code my friend did send me on Pancake sniffer. So Pancake sniffer is a code that you can be able to sniff the Pancake or the Binance smart chain, so that when an airdrop happens, you receive it the first person. That's something that I'm trying to see if I can be able to like work with. So yeah, so what I will do is Truffle. Should be Truffle migrate. Yeah, it should be Truffle migrate. Truffle. Yeah. So we will be redeploying. Okay. One thing I have done. Wow. Something that I have remembered I haven't done. Deploying script. We didn't complete, like we whatever we would have done, we would only have deployed this one. So yeah, let's complete on the deployment script. So always begin when you want to deploy. Always remember the deployment script once you have completed your contract code. So we'll go to our migration file, and yeah. So under our migration file, we will declare a variable ADS that will store the deployed script, the deployed contract. And then here we will now do the deploy. We will deploy the ethswap. ethswap. So we deploy the ethswap. We'll do await just like there above, and then we have deployer dot deploy. Then we should actually first of all require or import require swap equals facts dot require it should be swap. It should be ethswap. Yeah. And then we pass in the eth. We'll pass in the eth swap there. And then So what we want to do is this variable that we have defined here will be our contract. So once our ADS token has been deployed, will be stored in this variable ADS token as ADS token. And this variable, we will now be able to get the address of ADS token once it has been deployed. ADS token dot address, like that, dot address. So once we have been able to deploy, the variables will be stored at ADS, and then we will pass it here. So you remember here, we really require the token information in ETH, this one, token information. And this token information, we will be communicating with the ethswap. We'll be communicating with the ethswap. And the only way to do that is to pass the address of the contact, the contract ADS. And then after that, we'll do something called, we will transfer, transfer all the tokens to ethswap. So we'll transfer all these tokens to the swapping address. We will transfer all these tokens there, this particular place. Yeah, this particular contract, the address of this particular contract. And yeah, so that will be await token transfer. Wow, what am I writing? Transfer, and then we will pass the ETH. We haven't declared the ETH swap, so let me just copy this one. So yeah, and then we will do the same for this. So this address, the address of ethswap, where all the coins will be going to, will be pasted there. So ETH swap dot address of the address of ethswap, so that it will be the one to receive all the tokens. So this, yeah, will go to the exchange. All these token will go to the exchange. And then we have to copy. Remember, the amount of token we had was 1 million. So we'll paste it here. Just paste it there. So we will transfer almost all the tokens there and there. So we have actually completed our deployment script, So always remember the deployment script, because the deployment script is what is really most important. It's what you want to deploy. It's it tells the traffic what you are deploying. So if we had gone ahead in deploying, we won't be having the ETH swap because we haven't declared it here. So these are not necessary. These are not necessarily supposed to be there. You can just comment them all just and see how it works. But you can always, it's just the way you want, the architect of how you want your, if you want to access your kitchen door from the bathroom, well, that's okay. That's okay. If you want to access your bedroom from your kitchen, that's okay. No problem. It's how you want to, like, create your smart contract. Yeah. So if you want all your tokens to be, held by the swap, it's okay, because basically that's what Uniswap has done. Some of their coins are held in the swap, and then the others are held in the different places. I'll do a research on how they have handled that. Yeah, but basically it's something similar to this. Yeah. So migrate, because There is something what is called TD. It's token distribution. So you need to kind of come up with a token distribution chart, how you want your tokens to be distributed. Yeah. It and enter. So we'll do transform migrate and so let's just wait and see how it goes. And yeah. So sometimes it does take a lot of time when you are doing this deployment. So there is something which is really great is when you do a deployment and the code works within the first 1 minute. That's the best feeling you can ever have. Hello, don't know if you guys are still here. Hello. You can type on the chat if you are here.
Yes, I'm following.
Oh, okay. So yeah, let's just give it a minute and then it should deploy. It should deploy. Yeah, nice one. So this is the moment. Yeah, so you see it's compiling the 2 contracts and it's starting the migration, replacing the migrations. So it should have 3 deployments. And we have a problem. Wow. So it says that token is not defined in deploy line 3. Awesome. It's really awesome. Yeah, I know why. I replaced this one with ADS. So yeah, but it's good. We have had an experience where Truffle is not working, or as our deployment was not successful. Yeah, so you see, if you most of the time it will be the variable declaration which has an error, and yeah. So let's redeploy.
Babe,
Yes.
mbona mtu ame
Mtu?
Oh, sorry.
Okay, so it's okay. You can go ahead. Hello. Hello, Damaris.
Sorry, you can. I had not written.
You had not?
I was speaking to a different person. I thought my mic was mute.
Oh, okay. So I thought it's something yeah, so let's do the redeployment again because we have fixed that error. And awesome. So we are deploying again and gas fee. So yeah. So we are good now. We have deployed ADS. We have also deployed ETH. So this one has to do a repressing to create a new ABI for ADS token. And then here we did another migration for the ETH swap. So if we go to our build contracts or ABIs, we should be able to see ABIs for ADS token, and then we have the ETH swap token. So yeah, so this actually completes the first session of our backend. So next week we will do the Ethereum the front end, and then we will be able to see how we can be able to do that. So I've created a starter pack or a starter kit on my GitHub. I think I should share. So once we have completed, now you can be able to visualize and see how we can be able now to do this. Yeah, so the moment when you will be swapping, you will be like, oh man, I know how these work. You'll be like, I know how this thing work. Yeah, and that's a good feeling when you know how things like the back end, how it works. So let me share with you the starter pack I have created. I know it will somehow give you some errors. So I was trying to fix it because it's a node package. Not that one, not that one. Wow, I need to close some of this tabs. I feel like we can go on. Yeah, so this is the starter pack or starter kit I created. It's a Java React JS. It's combination of JavaScript and Solidity, and you can use it. You can use it for you can download it, and then we will be able to use it. Just forget about that. I'm thinking of I'm doing a series for like 30 days of Ethereum. 30 days of Ethereum. It's like a refresher or something. Yeah. So there, that is the starter kit. So you can download it, and on Monday, I will also help you on the same. If you have any problem, you can always reach out to me. I'll be able to help if you have a problem. Yeah, and of course, if you encounter a problem, Google has the answer also, and Google is already available before you, yeah, before me. Yeah. So that is the starter kit. So what we will be building on Monday is this part now. Is what we'll be building. It will be this part, and so we'll have the buy and the sell. So currently now, so this is the function that we'll be accessing with the buy. So we will be accessing this function, this buy token. So we will be accessing this buy token. So if we want to buy, you see we are inputting the value of ETH. So here we will be here we'll be inputting 2, and then we should be able to see the value of coins here that we will be getting automatically. It should be calculated. So I haven't completed because I'm trying to like redo this application so that it will be available for you in your current Node.js, because I'm using version 9. I'm using version 9 of Node.js, and right now I'm trying to convert it to 14, because I believe you guys are using 14 or 16. Yeah, so that you don't have a lot of trouble. I'm trying to convert it into 16, and yeah, 16. Yeah, because you downloaded version 16 or 14. Yeah. So if you have any question, I know it's Saturday, but I'm still asking concern or question, comment, anything. Yeah. Hello.
Yeah, no question. I think what you can do for us, this screen, maybe we can share it, and then let's try it out so that on Monday we come loaded with question.
Yeah. So on Monday we can do we can do. Oh, you want us to complete this part all?
Sorry?
Monday awarded us to do the front end so that we can conclude using the front end, because yeah, that's why I wanted us to cover.
It's okay. It's okay.
So that's why I wanted us to cover this this part today, this ethswap. So I'll be uploading this code so that it will be available for you, the ADS, the new version, and also this one, so that you can practice. I won't say over the weekend, over the next few hours. Yeah. Yeah, so that you can at least do some practice, and yeah, so that I think if there is no question, then let me stop sharing, and then I can stop more.